Good morning, everybody. Thanks for coming out so early on a Monday morning. It's good to see you all. And I'm Deb Carver. I'm the Dean of Libraries. And Don Harris and I have kind of jointly sponsored this program today. We're so fortunate to have Clifford Lynch here. Clifford is the director for the Coalition of Networked Information, which is co-sponsored by the Association of Research Libraries and EDUCAUSE, two organizations that the University of Oregon is a part of. The focus of CNI is on the use of information technology and networked information to enhance scholarship and intellectual productivity. Clifford has a PhD from UC Berkeley, and he's also an adjunct professor in Berkeley School of Information. So prior to joining CNI, Clifford served as Director of Library Automation for the UC system. In addition to his focus on the infrastructure of digital libraries, Clifford has been closely connected to developments in open access, institutional repositories such as our Scholars Bank on this campus, and e-research and digital scholarship. Prolific speaker is a gross understatement in this situation. I think most academic librarians and perhaps many IT people have already heard Clifford speak before. But one thing you never hear people saying is, oh yeah, I've already heard that guy. Because every time Clifford gets behind the podium, he has something new to say. He's tracking on trends and developments, not just in the IT world, but in other sectors as well, and not just in this country, but globally. So he's tracking the trends, but at the same time, he's also offering us insightful analysis. So we're most fortunate to have Clifford here today, given his fairly wild schedule. Don Harris and I have asked him to speak on the unique challenges associated with the growth of interdisciplinary, interinstitutional, and data-intensive research. We scheduled the room for about 9:45, and Clifford's going to speak for about 45 minutes, but then we're really hoping to hear your questions and open it up for a dialogue. So please help me welcome Clifford Lynch.
Thank you. Can everybody hear me okay? Great. It's very nice to be here. It's very green outside. You know, we don't get this for but a tiny part of the year in the part of California where I live. So it's wonderful to see this kind of verdant green. I thought that what I would spend some time with you on this morning, and as Deb said, I'm going to try and keep my comments to about 45 minutes, which should give us some reasonably ample time for conversation at the end. What I want to do is start with some of the changes that seem to be occurring broadly in scholarly practice. You've certainly, many of you, I'm sure, over the years read, for example, all kinds of overwrought articles about revolutions in scholarly publishing and things of this ilk. I think, though, that to really understand what's going on, you need to start with the root activities of scholarly work themselves, not with the manifestations in terms of things like publishing systems. So I'm going to start with a few comments there. And then I'm going to talk a little bit about what these mean for institutional support services, and indeed for institutions that act as both hosts for scholarly work and as curators of scholarly work. And then I'll conclude with a few comments about how some of this also plays into the world of teaching and learning as well. So that's where I hope to go in the next 40 minutes, roughly speaking. So let's start with some of the changes in scholarly practice itself. there are wonderful words afoot in the world. If you talk to people in the US science agencies in particular, you'll find that they are very focused on what they term cyber infrastructure now. There is an office within NSF basically sitting at the same level as the various disciplinary directorates, reporting straight to the director's office at NSF now, called the Office of Cyber Infrastructure. It's run by Dan Atkins, formerly of the University of Michigan. You will also find cyber infrastructure type activities taking place at the Department of Energy, at the National Institutes of Health, many other places. Now, if you go across the Atlantic to Europe, you'll find that they prefer to talk about something they call e-science, or now more broadly, e-research, recognizing that some of these developments actually go far beyond the hard sciences and engineering and really are, as I'll talk further about in a few minutes, having some substantial impacts in the humanities as well. In Asia, they talk often of cyber science, interestingly enough. All of these are really sort of shorthand for the same thing, though. It's a set of observations about the fact that scholarship is being changed by a series of factors that include the use of high-performance computing, the use of advanced networks for two purposes. One is to talk to collaborate with other people. The other is to reach experimental, observational, sensor, and similar resource tools that are used in science. It recognizes the importance of simulation, visualization, and similar sorts of techniques as an important method of scholarly inquiry. It recognizes that more and more various kinds of scholarship have come to rely on the ability to create, to share, to annotate, to manage large databases which represent both evidence for inductive examination and also document results. And you know, it's really quite startling to see the range of areas that this applies to. I was just looking about a week or so ago at some work in fairly abstract mathematics where they were actually computing enormous databases of symmetries of Lie groups. You know, you tend to think of mathematics of all things as, well, all they really need is pencils and paper, right? We love them. You know, their instrumentation needs are really inexpensive. But even in areas like this now, this is becoming pervasive. Now, I certainly could point at enormous numbers of developments in the sciences to persuade you of this, and you know, I'll just mention a few. Certainly, if you look at the life sciences, at molecular biology, genetics, and related areas, it's clear that various kinds of high-throughput sequencing have become very important. Databases of signaling pathways and similar kinds of things have become critical. You actually see projects now doing some very interesting things with shared instrumentation. For example, they have done things like connected electron microscopes to the network and are sharing them across the Pacific at this point. If you look at the environmental sciences, those have clearly become massively data intensive. Not just the remote sensing platforms that orbit the planet, but indeed you've got very interesting work going on now about people who want to be able to deploy rapidly these very sophisticated sort of multi-level sensor networks. At the low end, they refer to it a little bit grandly as smart dust. The idea that you can just sort of scatter these sensors out there. They've got very low power radios in them. They self-organize. They sense various things of interest, and then you kind of roll up the telemetry. There actually are even more interesting things going on where you combine this sort of lots and lots and lots of cheap self-organizing sensors if you're trying to do, say, ecological studies with robots that can move around a little bit. So you've got a more expensive sort of walking lab or observation device which can go roaming around in the area you're interested in to take a closer and more intensive look at phenomenon that the cheap sensors have picked up. So there's a lot of interesting things going on here. Astronomy is an area where we've seen some really striking changes. The growth of national and international virtual observatories. Now, this is actually worth spending a minute on because it's such a sort of an elegant way to see these developments. It used to be that what astronomers mostly did was they wrote grants to get observation time someplace, and then they hoped the weather was good, and they'd go to these remote places and take some observations and go back and study them. Well, now, because the observatories keep copies of most of these observations as well as the actual astronomers making them, we've started seeing the compilation of these sky surveys, essentially, where essentially you build up a database of looking at various parts of the sky at various different wavelengths and various dates. So you build this enormous sort of synthetic observational database. And in fact, this is becoming so much part of the fundamental evidence of astronomy that they're now designing these sky survey systems that basically feed these databases independent of specific observation. Now you're seeing astronomers who actually are writing grants to basically run algorithms against these databases to discover new objects. It's really quite an fascinating expansion of the activities of astronomy. There are a couple other things that are worth noting here too that are just intriguing. One is that particularly as we build these sort of automated survey instruments, most of the observations that are flowing into these virtual observatory databases are flowing in unseen by human eyes. Essentially, they're running against filters of various kinds, which look for objects or behaviors or groups of spectral phenomenon of interest, and if they match the filter, it's kicked out for human attention. Otherwise, they're just aggregated in these databases for study. Much of the sort of frontline observation right now is actually being done by amateur astronomers. I need to qualify that word amateur because it probably, for you, conjures up a 50-year-old image of some, high school kid with a little telescope in his backyard. In fact, the combination of cheap computers, sensors, and improved optics have put your amateur, by which I mean he or she probably isn't a faculty member in astronomy at a university, they've given them astounding capabilities. And in fact, this whole kind of symbiosis between amateur scientific communities and professional ones is starting to be rearranged. You see this in other areas as well. For example, studies of biodiversity is another place where you've now got a lot of so-called amateurs who are armed with GPS receivers and other sorts of devices, being able to do rather heavy-duty observational work. So those are, just a few sort of haphazard examples of the kinds of work that's going on in the sciences. I want to stress one point, though, which I think is really important, and I'll come back to later. You've got a lot of talk in the science agencies about cyber infrastructure and e-science, this sort of thing. They tend to focus on sort of high-end national and international scale projects. They love to talk about things like the Large Hadron Collider at CERN, mobilizing, thousands of high-energy physicists around the planet and using a global data, analysis and dissemination network. In fact, a lot of these changes aren't just happening at the high end, at the sort of big international hero project level that's very heavily funded. These changes are actually working their way into, this sort of routine doing of science in various disciplines, lab after lab after lab. Just think about if you go through various scientific labs on a campus like this, how pervasive now you find lab equipment that's interconnected to computers, often in nasty ways. One of the charming things about this is often they calibrate and certify the computers and then never want to touch them again, so they do things like don't apply any of the security patches or other maintenance that's been issued for that computer for the last decade because it works. So you wind up having to build, yes, I see you smiling, special, sort of security firewalls around this stuff because it is so vulnerable. I actually, there are interesting stories in this area. I'll tell one that I'm not sure is true or not, but I have no trouble believing it. They make these very expensive MRI machines, right, which have lots of computers in them. And this is the sort of thing that the FDA gets into. And they basically have to certify that these machines do the right stuff. And apparently, you really don't want to recertify one of these as a manufacturer because it's a very expensive process. So apparently, there are substantial numbers of these that come with network connections, but if you plug this into a network, somebody's going to own your MRI machine within seconds because it includes all kinds of old operating system bugs that nobody's been able to update because you'd have to recertify the machine. These are some of the challenges we face with this kind of stuff. But the fact of the matter is that this kind of computation, reliance on data, the need to carry data forward has become pervasive. I want to make one other point about the perspective of the funding agencies here, which I think is important. I believe that there is a growing recognition among funders, and this includes both federal funders, people like NIH and NSF, but also private funders like Mellon or Wellcome Trust or indeed various state funding sources, institutions themselves. They're all recognizing that the data that comes out of scholarly work is in fact a valuable asset. It's an asset that we make long-term investments in, and it's one that we've done a very bad job, by and large, of treating as a lasting asset over the past decades. We've done a bad job in a lot of different dimensions. One dimension is that we haven't been treating it like it's very important. Case study, Katrina, Wilma, the rest of the great hurricanes. The deployment only rather recently at many major institutions at any scale of network-based storage that scholars can use to ensure that they haven't got some kind of geographic point vulnerability for their important research data. Data sharing. The norms for data sharing are very different from discipline to discipline. In some disciplines, the journals, interestingly enough, have taken the lead in ensuring certain kinds of norms about data sharing by saying, we will not publish an article about protein structure unless you deposit your protein structure in one of this very short list of approved repositories and you cite the accession number in your paper. In other cases where, for example, funding is very concentrated through a single source, something like, say, planetary science, you see pretty well understood norms within the community that say that the principal investigator and his or her team get 2 years to exclusively work the data, and then it becomes open to the community. So we're seeing rethinking of data sharing norms, certainly, one community to the next. You're also seeing funders putting strings on this sometimes. You are starting to see funders say, well, you will make data public within X months of publication or X months of capture. Indeed, you're starting to see a few things that I think are really intriguing. For instance, some of the foundations which have been established that are focused specifically on treatments and cures for individual diseases like cystic fibrosis, and that tend to fund rather focused research around those diseases as opposed to more fundamental research in the life sciences. Some of them are apparently now starting to put language into their grants that basically, if you'll allow me to be a little crude, say the purpose of giving you this grant is not to underwrite your expansion of your CV. It's to make rapid progress in curing or at least providing some alleviation to this disease. And because of that, we expect you to share pre-release data with other people we're funding before you even publish on it, because that's why we're funding this. So the whole way people are thinking about data is changing. We're seeing NSF, NIH, other organizations starting to ask in their grants for data management plans that basically say, they basically are an invitation to the grant writer to try and convince the review committee that the principal investigator on this proposal has thought through what are the data assets that are coming out of here, who are they likely to be useful to, and how are we going to get them there? Now, it's important to recognize that the assumption is not that every grant that's funded produces bottomless, amounts of usefully reusable data that needs to be preserved for all time, but rather that many grants produce some of it has a relatively short lifespan, some of it may have a very long lifespan, and somebody needs to think explicitly about that as part of the responsible construction and administration of a research funding program. So we are seeing this. And a final piece of this is that it requires that we learn to organize data, to annotate it, to curate it in such a way that it can move from one researcher to another, and that it can move across time, and that the recipients of the data are able to interpret it and make good use of it. It is worth observing that very little data really exists without software, and implicit but largely not talked about openly in this is the very extraordinarily difficult challenge of how we preserve and share not just data, but the software that allows us to work with the data across time and across different centers of work. So that's a kind of a quick look at what's going on in the sciences. Now, if you're interested in, sort of further details on this, I'd invite you to have a look at the various reports that you can get off of the NSF site, out of the Office of Cyber Infrastructure there as a place to start. There's a very good one on long-lived research data sets. There's an overall vision document that NSF just released recently in sort of final form. There are an analogous series of reports that have come out in the UK and some in other places. But I want to take a minute here to look beyond the sciences, because when this conversation started, it was very much focused on science and engineering, the kinds of areas that the National Science Foundation and the National Institutes of Health and similar agencies fund. If you went and you stopped biologists or physical scientists going in or out of the appropriate building on this campus, and you asked them something along the lines of, well, wouldn't you agree that the way you practice your science is different than it was 30 years ago, and information technology and related developments have something to do with this? This would probably not be a controversial question, and most people would agree with you and move on. This is not the case in the humanities, where you find this sort of wild variation from discipline to discipline and from individual to individual about the relationship between information technology and the humanistic enterprise. Most of them, in fact, almost all of them, especially if you get them off the record, will admit that the telephone changed some of their practices, that email was actually a really big deal because they mostly didn't have budget to use the telephone internationally to talk to their colleagues. You laugh, but I am ancient enough that I remember living through the sort of large-scale introduction of email on university campuses in the late 80s, early 90s kind of time frame. Now, yes, there were people, as early as the early 70s, little cadres of people with glass teletype terminals trading email over the, original ARPANET. But this was limited to a very small percentage of the campus population. The arrival of email in many of the fields beyond sort of computer science, engineering, and certain computational bits of science was really just a transformative experience. It allowed people who wanted to talk to other people who they would only see once, twice a year at conferences, that they actually used to write letters to. And not only would they write letters to, they would entrust them to the unreliable international post, which might take a really long time to deliver it, if at all. all this was replaced by email. This was a really big deal for humanists. There are a few other things they'll admit to. Many of them will admit to using word processors to write their books. Almost all of them will admit to using certain kinds of electronic databases in order to do research and reference. They will sing the praises of various abstracting and indexing databases. They will wonder how they lived before JSTOR, a few resources like that. But when you get this question of, well, is it really changing the scholarly work you do? It gets very squirrely. The American Council of Learned Societies set up a commission a couple of years ago that produced a final report last year on cyber infrastructure for the humanities and social sciences, where they basically argued, and I should fess up, I was an advisor to this commission, that you can see unevenly distributed, but certainly visibly, some really innovative, groundbreaking applications of information technology and this sort of e-research in the humanities, and really across the whole range: linguistics, economics, history, archaeology, art history, architecture, language studies. There are fabulous examples of what you can do in all of these, but only a very small number, relatively speaking, of scholars in these disciplines are pursuing these things now. And their work is often quite controversial within the disciplines. It's also interesting that if you read the ACLS report, it calls for a cyber infrastructure to support the humanities and social sciences, which is quite similar in many ways to the cyber infrastructure that's talked about for science and engineering, but also different in some important ways. If you look at the evidence, if you will, that is needed to support scientific research, by and large, it comes in two flavors. There's the journal literature, and then there is data, various kinds of historic data, observational data that has been collected to and that's needed to support various kinds of scientific work. If you look at the scientific journals, they have made now a transition to digital form. It's been a very literal transition in the sense that a scientific article in a modern digital scientific journal would, if printed out, be absolutely recognizable as a scientific article to any scientist from the 1950s. The way we communicate in terms of sort of genre and structure and things like that hasn't changed very much, except that we include a little bit more color graphic stuff. And we make reference to ancillary material in the form of various kinds of data sets and similar materials. This is another question which we can go into later about why that is and when that's likely to change. But the important thing to recognize is that in doing that transition to digital form, they actually have systematically converted the back files back to day one of most of the scientific journals. So you can, in fact, get the Journal of the Royal Society back to day one. In some cases, this conversion is still ongoing. So the American Institute of Physics has done all their stuff back to day one. I think the American Chemical Society is still working on it. But it's clear that in the cases where it's not complete yet, that this work is underway. There's significant funding in it, and it's going to get done, and it's going to get done within a reasonable sort of time horizon of this decade, I would say, or give or take a few years. And at that point, we'll have pretty much all of the hard scientific literature in digital form. Now, this does not mean that everybody can get to it, of course. It's still copyrighted and licensed by somebody, but we've made the transition. The humanists are a little bit more ambitious. Their take is they would like all records in all forms of all human civilizations and activities in digital form. They'd also like the artifacts, of course, kept as well, because sometimes there's just no substitute for that artifact. But they'd like it all digitized. All of the sound recordings, all of the images and artifacts in museums, all of the vast amounts of literature that fill our great research libraries. They speak of all of this as being part of the cyber infrastructure for the humanities. And you can make some very interesting connections here to things like the large-scale digitization programs that Google is carrying out in conjunction with a number of major universities in the US and abroad. You can, and of course other projects like the Open Content Alliance, various activities to digitize museum content. All of these things begin to play into at least initial investments in some of this cyber infrastructure for the humanities. It's probably worth making a cautionary note here, and I don't think that the ACLS report is quite strong enough about this. We have almost no experience with digital libraries on that scale of book-sized objects. We have some experience now with journals. We have a lot of experience with digital libraries of web pages, otherwise known as the web. But we don't really know very much about what happens when you take 10 million books and try and make them usable online. I think we're going to learn a lot. There have been a few helpful, initial explorations in this. I'd point you, for example, at the work of Greg Crane in the Perseus project at Tufts University as one of the leading explorers in this area. But I think one of the things we are going to do over the next 15 years is we're going to start sorting out what we really do with these sorts of corpora. I'll just give you one example. We historically have had a very simple-minded view of the journal literature, that what you do with it is you read it. Human beings read journal articles, and that's what's done with them. The other thing that's done with them, of course, is you Xerox them, or more recently, make hard copies by print on demand. You pile them up on your desk, and you absorb the contents through an osmosis sort of process as you move the pile back and forth and never get to reading them. But those are the two fundamental things that you do with journal articles. Now, what's so interesting is that in the last few years, people have realized that you can do something else with journal articles, especially when you get millions and millions of them. You can compute on them. You can actually do computation on these very large corpora of knowledge representations, and it's knowledge represented in a nasty way, human language, with all of its ambiguities and complexities. But you can actually go in there, and you can bring to bear tools like thesauri and ontologies and gazetteers and other sorts of things to help you interpret what's in there. And you can start constructing scientific hypotheses. You can start making connections that no human being ever observed before, because there were these two things in two, rather different bits of the literature that were really the same thing called different things, and it can make the connection. Of course, there are people doing this in other areas as well. This kind of text mining is of great interest to various folks in the intelligence sector who have been investing very heavily in it for decades. But those kinds of technologies, now that we've got the bases of content in digital form, are starting to get applied. And this is, I believe, going to fundamentally change the way we think about what is a literature and what do we do with it over the next, say, 20 years. It may actually indeed change the way we author. We may find the scholarly article of 2025 is actually structured in a way that explicitly recognizes that machines as well as human beings are going to be rooting around in it, and puts in a few cues to help machines, so that maybe instead of guessing whether this is the name of a particular gene, you tag it as gene name or something like that. And that's a very trivial example. There are people starting to explore this at the moment. I think it points in fascinating directions for us. Okay, so that's a few words about where the humanities fit in. I think that the most important point to recognize is that this is not, this change in scholarly practice is not simply isolated to science and engineering, that it really reaches across the entire spectrum of scholarly activities. It's even showing up in places that are quite interesting, like performing arts. If you've ever watched people doing musical performances now across the network, it's become quite, where performers are playing together in geographically separated places. When you look at our ability to capture and document things that historically were extremely ephemeral in that they were performed and then they were gone. This is, I think, going to have some deep effects in places like performing arts. Okay, so these are a few of the ways in which I think scholarly work is changing. I've mentioned, as we've sort of gone along, a few of the ramifications for scholarly publishing and communication. And I think rather than delving deeper into them, what I'd like to do in my remaining time is to make two sets of observations. One is about how this connects with teaching. The other is about how this connects with institutional activities and support and organizations. And let's talk about the teaching thing first. I think that we need to recognize that the portfolio of teaching activities in a major research university is hugely diverse. And I think that we do ourselves a disservice by trying to make sweeping statements across the whole thing. And there are lots of popular kinds of sweeping statements. There's the set of sweeping statements about only dinosaurs give lectures anymore, and these are the most appalling things, and you've all heard that rhetoric. I can remember my life being changed by enormously talented lecturers, when I was way up in the bleachers someplace and, just rapped for an hour, twice a week. That's a gift. Not everybody has it. It's not suitable to every kind of material. It has a place. I believe it's going to have a place for the future as far as I can see. We're also going to see, though, the introduction of a lot more things that combine research with teaching. There's this whole emphasis that's starting to emerge now on engaging students earlier and earlier in their academic careers, undergraduates, as high school students, with direct research and engagement in things, whether it's source materials for history, which we can now do as we digitize our special collections, or whether it's observational work in the sciences or whatever. Some of this investment in cyber infrastructure is going to give us wonderful opportunities. I told you about the virtual observatories a few minutes ago. Well, one of the things they did there was they put a second interface on the database that was really designed for school kids, so that as a school kid, you could go and observe the sky at the date and place you were interested in and look at objects in there. You could go and, steer your own virtual, very expensive mountaintop telescope. And, this is a very striking way of how you can change the equation for students. Another one that I think is very interesting and bears some consideration is the rethinking of lab. It used to be that you put kids in high school, certainly, or introductory courses in college through these lab activities in elementary chemistry where you'd titrate things, or you'd dissect a frog in elementary biology or something like this. And this is actually very expensive to do. It means nasty, hazardous chemicals and things like this. It's not clear how useful this is in some cases, at least to me. You're actually seeing people build virtual labs now so that you can do all this stuff on the computer without the chemicals and the dead frogs and stuff like this. This is something I think we need to think very hard about, because there is, I think, an abiding importance in tinkering and in giving people opportunities to tinker. There's no substitute, particularly when you're trying to produce people who understand a certain kind of research, for getting your hands dirty. But I'm not sure that the way we've been doing it is the most cost-effective way to do it. And I simply, frame this as something that I don't think has a right answer, but expands our choices and challenges us about where to make what choices. I think there are a couple other things that need to be pointed out about cyber infrastructure and how it interacts with teaching. One of the other ideas that's fundamental to cyber infrastructure is that of collaborations. The ability for teams of researchers to come together to use various apparatus, to make observations, to analyze data, to write, to solve problems of various kinds. More recently, they've been using what I think is a very helpful term, virtual organizations. Basically trying to convey the notion that you need to be able to build these teams quickly, fluidly, agilely. You need to be able to put them in place across institutional boundaries, across national boundaries, and then break down the organization when it's finished what it's doing. Some of them will stay around for a long time. Some of them will be rather short-lived, I believe. And it becomes possible now to bring students into these activities in a way that wasn't possible before because it was just too expensive. It, I think, will engage students much more in the processes of research on a broader basis. Another property of these collaboration environments is a lot of the activity that goes on with them is recorded in a way that face-to-face scholarly activity wasn't. So you actually will see people sort of replaying and further annotating data analysis sessions that they couldn't attend in some of these collaboration environments. I think there's some very interesting possibilities there. A word about learning management systems. You know, this is another situation where at one extreme, basically what we're doing is automating things we always did, you know, like handing out the syllabus at the start of the class and the reading list and the problem sets and the answers to the problem sets and things like that. It's not very exciting. At the other extreme, though, it's worth noting that people are now starting to talk about some of these learning environments really as more fundamentally collaboration environments. There's a big open source project called Sakai, which is basically building up a collection of what you might call learning management software. But they're actually thinking of it a lot of the time as collaboration software. And it's quite striking that at some of the early adopter institutions, you are finding not just classes with spaces, workspaces on Sakai, but indeed faculty committees, research groups, people planning conferences, task forces, all kinds of things. So the move from pure teaching environment to collaboration environment here, I think is quite notable and is going to have some interesting ramifications. Now, let me just close with a few comments about some of the support issues here. 20 years ago, when information technology really started to roll out to faculty on a very broad scale, there was an enormous demand for IT support. And this is IT support at a pretty fundamental level. How do I work a word processor? How do I do email? How do I get my workstation plugged in and set up and on the network? These are things that today most people are expected to know how to do. Most students, by the time they get to university, are on their second or third or fourth computer. They know how to do this. I'm sure all of you have seen the various opportunities that folks like the Recording Industry of America have taken to characterize universities as these hotbeds of interchange of what they characterize as illegal copies of music. Now, interestingly enough, I saw data from, of all places, the RIAA, presented publicly a couple of years ago that suggests that, indeed, you don't go to university to learn how to do this. You come in knowing how to do this. This is a set of skills that are well mastered as part of basic information technology literacy in middle school and high school. All you do when you get to university is enjoy a better network. And I think there's some truth in there. The whole sort of expectation about level of computer literacy has shifted immensely in that 15 or 20-year period. I've recently, over the last year or two, looked at a number of studies that have been done at major universities about the research support and teaching support needs, but predominantly research support needs of faculty and graduate students. And the message that I take from these is that it's really not about, how do I work a word processor and get my mail anymore? This, to the extent it's a problem, seems to be a fairly easy one to deal with. It's much more about how do I structure my research data? How do I curate it? It's about how do I organize it? What do I do for a backup scheme? How do I handle migrations? These are the kinds of questions that start showing up. And these are questions that, interestingly enough, fall somewhere between kind of traditional IT and the sorts of support that libraries have historically given to the community at universities. At the same time, and this is not I'm not persuaded this is a global trend, but it certainly is a documentable trend at least some big campuses. What you've seen is a sort of a redistribution of function away from a central IT organization that did everything to a central IT organization that worries more about infrastructure, about the network, about running servers and clusters, maybe about running enterprise financial systems and things. And what you've seen is the emergence or the considerable growth of computing-related job titles, information technology-related job titles in schools and departments out there close to the graduate students, close to the researchers. And in some cases, these folks have gotten fairly involved not just with IT, but with data as well. A very common example would be some kind of GIS center. Another very common one is social sciences data centers, where a group of departments will fund some people who work with faculty and graduate students who have expertise in the kinds of statistical tools that are commonly used in social science, but also know some of the main databases. They know something about census data, something about GIS data, something about the kinds of stuff you can get from ICPSR. So they're moving out there closer to the departments. Now, as we see this increased emphasis on the importance of viewing research data as an asset that has value over time, that needs to be curated and shared, one of the things we need to ask is what kind of organizational structures make sense there? At the high end, what you're seeing today is mostly integrated support. If you can get a $10 million grant to do large-scale biology, you can afford as part of that grant to build in a couple of biological informatics people, and they do. And there are people who actually are very specialized in that area. If you're a smaller operation, you know, a 3-person lab, or even a humanities scholar working in relative isolation with a graduate student or two, that doesn't work. And indeed, we're going to need to look for institutionally based solutions to that, I believe. The high-end molecular biology folks are going to set up national-level disciplinary repositories to a great extent. The funding flows in for that. It's easy to forget, especially if you come out of the sciences, but provosts, I think, are very conscious of this, that even in a top research university, a very considerable proportion of the faculty don't get grants. Or if they do get grants, they're very modest grants to go someplace, to buy them out of teaching for a semester or to work on their book and send them off to, look at material in some archive somewhere. Those are the kinds of grants, if they're getting grants at all. That's very different than the world of big science. And I think that we face a very real challenge in building organizations and coming up with funding models based in our institutions, which is where I think they will be based, in order to support this kind of scholarship that the institution hosts and to see to the sort of long-term curation and preservation of the results of that scholarship. So those, I think, are some of the central organizational challenges which our institutions face as we try and adapt and recognize and indeed, where appropriate, try even to accelerate these changing, this changing character of scholarly activity and practice. So I hope that that admittedly very fast and very sort of episodic and anecdotal survey at least gives you a feel for some of the changes that I'm seeing, for some of the roles that the funding agencies are playing in this area, some of the roles that institutions are going to be thrust into in responding and supporting to these changes in scholarship. And with that, I'm going to stop, and I would welcome your questions or comments. Questions, comments?
Yeah, at least 10 minutes.
Take my pick.
Let me reflect my lack of understanding more than anything else. But going back to talking about virtual labs, you said that tinkering, if I understood, you said tinkering is sort of essential to the discovery process. I guess I'm wondering if the tinkering gets limited by the data that gets input. People have some preconceived notions about something. They enter certain kinds of data for these virtual labs. Does that limit what can be discovered?
Well, okay, I probably did not say that clearly. The question is about the relationship between virtual labs and sort of learning to discover and tinker. I guess that the way I'd put it is the virtual labs are pretty flexible because they usually have fairly elaborate knowledge bases of things like chemical reactions in them. And in fact, it's quite reasonable to let people try things in the virtual labs that you'd be very uncomfortable letting them do in a wet lab because they don't necessarily have the lab technique and close supervision that you'd like with that set of chemicals, and you also don't want the expense of getting rid of the results of the reactions later and things like that. So in that sense, they're actually, I think, more open-ended. To be fair, a lot of the experiments that you do in, say, high school science aren't about discovering anything. I mean, they're just a way to torment children more than anything else. What I was referring to more was that I think that there still is a place, and you see it again and again in scientific breakthroughs, for people who basically are very insightful about lab technique and the construction of experiments, and who know how to do things like build sensors. And at some point, you want to make sure that people who are interested in that and have that talent get a chance to do that. You don't want to squeeze all that out. At some point, there's no substitute for building something and having it not work. Yes, sir.
Where do you see the economic support for these, these curators, these high-speed networks, and these large collections of data coming, maybe outside of the obvious, like video on demand and consumers paying the price? What are some of the less obvious emerging economic markets for this information?
Okay, the question was about economic markets. I think that I'm not sure how much market per se there will be for a lot of this. Indeed, it's looking to me more and more like we are moving in science away from an era of highly proprietary fundamental databases and towards much more openness. For instance, in the late 90s, there were a ton of companies that were marketing various kinds of databases to the pharmaceutical and biotech industry. I mean, most notably, you had the attempts to privatize the human genome there and market it. And I think there is sort of a, big secular consensus emerging that we're better off making a lot of this stuff a lot more public. And so you're actually even seeing pharmaceutical companies in some cases open up some of their observational databases into this sort of public realm. So I'm thinking that we probably aren't going to see a big market in those sorts of things. I think you will see a growing recognition that part of the overhead of grants in the scientific area is going to be this kind of curation and support. In some cases, it'll be true overhead. In other cases, it'll probably be line itemed into grants. But I think the funding agencies certainly are making the mental transition that there's an investment here and they need to play a part in that investment. The bad news is that some of this, I think, is going to come out of core university budgets. This is what universities do. They create and act as stewards of knowledge. And it's pretty hard to think of something that is more core to what universities do than preserving and disseminating the research of their faculty. So in that sense, I don't think there's a magic answer to it other than perhaps we're going to have to see some funds reprogrammed from other priorities into this. I think that libraries, for example, are going to be called upon to do a good deal more of this in coming decades. And you may see it actually competing with more traditional library budgetary commitments like purchasing journals. Yes?
What you foresee, right now students come to the university, there's a university environment, culture. In let's say 20 years from now, how much of that do you think is still going to be around? And how much of it's going to be substituted or, with more digitized type of learning?
Ooh, that's a wonderful loaded question. The sort of quick version of the question is, how does the student experience as manifested in a place like this that you come to and spend some years here, what's that going to look like in 20 years? Are they still going to come for all of those years? Or are they going to get distance ed, or what's going to happen? There are a lot of ways I can get in trouble with this question. The glib answer is yes. All of those things will happen. When you think about what's higher ed going to look like in 20 years? One of the reasons that I think we have so much trouble dealing with this is that there's not just one higher ed. There are actually a lot of different types of higher ed experience that go on now, ranging from, you know, the sort of person from central casting who comes out of high school and goes and spends their 4 residential years at Harvard, all the way through people who, you know, attend 5 different schools on the way to their first degree over a period of 10 years in 3 different states, interspersed with, you know, families and jobs and other kinds of activities. There are people, you know, pursuing education at a distance who can't get to residential opportunities. There are people doing that who prefer it. I mean, it's a very confusing landscape. There's also, you know, a difference between people who are doing this to get a skill, to get a certification, and just because they're interested. You're finding a growing group of people who have enough time, retired people, for example, to learn about stuff just because they're interested. And the way you learn about stuff in that situation is very different than when the goal is to get a certification so you can get job X, or learn how to do something so that you can keep the job you managed to talk your way into, or whatever. So I think it's actually a pretty diverse situation out there. Economics are going to push it in some directions. There are more and more people who want access to higher education. You know, you could make the argument that in an ideal world, it would be wonderful if we could take every high school graduate and send them to Harvard for 4 years. And by the way, you know, somebody should pay for that too. Except that we'd run out of room in Cambridge, and it's just not going to happen. So you start looking at a much more complicated set of trade-offs. It seems really clear that there are some things we can do and do very well with distance education. It's also clear that smart combinations of face-to-face, not necessarily residential, but face-to-face education and distance education or computer-assisted education are very effective combos when used together. I mean, even in a residential school like this, I'll bet you that a significant proportion of your courses now have a virtual piece attached to it that adds on to and supplements the face-to-face experience. So I think things are going to be all over the place there. I think that one thing that you may find is that there will be less bad lecturers because you'll be able to watch really good lecturers somewhere else if that's what you want to do and that's what you're trying to learn about, because actually letting people watch lecturers scales pretty well. On the other hand, teaching writing is a very interactive kind of thing that seems to work best with relatively small classes and a lot of one-on-one. An interesting question is, to what extent are we going to be able to develop tutoring systems to supplement those? There are already some very interesting things going on in that area, although mostly in situations where methods and answers are fairly clear. For example, computational kinds of mathematics skills. So I think you're going to see a lot of diversity there. Some of it's going to be driven by economics. I saw some data the other week where somebody had been doing some rather extensive surveys of consumers. And if you look at the age groups from, I think it was a bit, I may have the details slightly off, I'm thinking 25 to 50. give or take. Their preference actually is for online education because they like the asynchronous quality, being able to get it on demand. They have lives, that put a lot of constraints on them in many cases in that age group. So they're real interested in that. To the extent that we're trying to reach those folks, you probably will see a growth.